Alright, so now we're going to talk a little bit about the experiment that we just did. So before we start with that, I'm going to recall the diagram that we always draw. Since we did a concave mirror, I'm drawing a concave mirror. Then I will draw this P, F and C. Right? A while ago I said that this distance and this distance is always equal. Right? So one fact that I know about the mirror is I know what is this distance for the mirror. It's called as focal length. So it is known to me, like on the packaging of the mirror itself, that the focal length F is equals to 10 centimeters. Right? So basically the distance between P and F is nothing but 10 centimeters. This is 10 centimeter. And we also said if this distance is the same, that also means between F and C, the distance is also 10 centimeters. Right? Finally, one thing I can tell is the whole length of my axis over here from P to C. Since P and F is equal to, F and C is also equal to 10. And P and C, this is 10 plus 10, which is 20 centimeters. Right? Right, PC equals to 20 centimeters. We're going to see why this is significant. Right, now notice that look at the trend over here. I started the objects from somewhere at 15 centimeters from the mirror. Right, if we know that 10 centimeters is the focus, so I put it a little behind 10. So if I look at it on the diagram, 10 plus 5, I started the image somewhere around here. So 15 is nothing but it's between F and C right now. If this is 20, this is 15, which is between F and C. So when I did this, this is between F and C. Alright, so I'm going to make another table over here on the top to try to understand our findings a bit more. Right, so the position initially, like I said, now is between F and C. So at 15 centimeters between F and C, the image when I put the object between F and C, so the candle being at 15, the image was at 23. Now if this is 20, 23 is somewhere here, correct? It's a little behind C. So I'll say next thing is nothing but, I'll just change the heading here. So this is nothing but object position. This is nothing but image position. I'll attach a table of this in the video. So if the handwriting is not clear, it is okay. Right? So when I say it's between F and C, the image is forming behind C. Right, now shift to the next one. So when I was at 20 centimeters, the candle was at 20 centimeter, the image also was at 20 centimeters. Right, so whenever my object was at C, exactly at C, my image also turned out to come at the same point at C. So whenever the object is at C, I will see the image is also at C. Right, finally we went from here to here. Now we are going at 25, which is nothing but behind C. right? So 25 will be somewhere over here. So I put the candle behind C or beyond C, right? So when I put the candle behind C, what happened is the image was at 17. So now if I look at this line, 17 is nothing but this is 10, 17 would be somewhere here, right? It's between F and C, not exactly in the center, but it's between F and C, right? So I will say between F and C. The distance would vary because when 25 is still behind C, even 40 is still behind C, right? So both 17 and 14. So 17 is here, 14 is over somewhere here. So this is 10, somewhere over here will be 14, right? So basically what I am trying to say is, once the object starts being pushed behind C, the image is going to appear somewhere in between these 2 points, between these F and C. It will start off from here, it will keep moving here. So if you notice, the object kept going far from the mirror, but the image kept coming closer to the mirror. So distance is reducing here and distance is increasing here. So candle moved back, image moved front. That is the trend that we observed over here, right? Now I know if my object is between F and C, at C and behind C, what is the result? The image is going to be behind C, at C and in between C. They kind of interchange. But one thing I did, if you notice, I put the candle really far from the mirror at 50 centimeters, right? It's towards the end of my table. Then you'll notice that my image formed at 10. Now 10 centimeters is nothing but from here, 10 centimeters is this point F, right, at focus. So whenever an object is put really far from a mirror, what happens is light comes almost parallel. So we kind of have a name for it. We say object is at infinity, okay, at infinity. Basically what I am trying to say, beyond a certain point, no matter how far I put the object, the image is always going to form at one point, and that is F. It is always going to form at the point F, which is exactly 10, and it will be a really small image, hardly noticeable, right? So these are 4 trends that we have seen so far. In terms of size, again another size, you'll see this was an enlarged image, right? This was enlarged. Basically it's slightly bigger than the object. If the candle flame is maybe this much, maybe the object image is a little bit bigger, right? Now once it came closer at C, you will see object and image have the same size, no difference. Object is the same, image is the same, right? But as it kept coming closer, you will see that the image kept reducing a lot, right? So diminished. Since this was much smaller, I will call it highly diminished, which means like very small, or you could even call it diminished. It doesn't really matter, right? So this is a trend in size, right? The farther the candle goes from the mirror, the smaller its image becomes. Now finally, one thing, that is orientation. Throughout we always saw only one orientation, that is inverted, basically upside down, right? So if the candle flame is like this is the tip of the flame, the image is always like this. I'll never see the image like this. My image is always like this, upside down, right? And that is the thing about curved mirror, concave mirror. Its images are always inverted in most cases. There is only one case where the image is not inverted, which we will talk about in a bit. Now these are 4 conditions that we saw: between F and C, at C, behind C, at infinity. There are 2 conditions more that are not something we can do with the experiment, and I'll tell you why. Okay, so if the object was here, here, here and beyond, There are two places I didn't put it. One is here, that is at F, and one is between P and F, right? I put it at C, but I haven't put it at F or between P and F. Two reasons for this. When I put it at F, what happens is the image that is formed is very far, right? It is a bit far from the object. Basically, it will be in the back. So like it will be enlarged, it will be highly enlarged. We will not be able to get a clear image at all, which is why I didn't do this case over here. And finally, between F and P, there is going to be no image formed over here that we can see on the screen, right? This image is not going to be something that can see on the screen. Cool. So those two cases I will write about them in the table that is attached with the video. I'll give you a snap of this. These are few conditions that come with any curved mirror, and it is quite an important topic. It's usually asked. We'll give you a blank table, give you some empty spots. You'll have to fill in those spots and complete the table, right? If you remember the trend, it's very easy to understand, right? Object comes close, image goes far. Object goes far, image comes close. Size decrease or size increase depending on which way it is going, right? Keep these few things in mind and you should be able to do it. Great.